It wouldn't be the first.
3.
Okay, what's going on? You gotta catch me up.
We're talking about that.
All right, guys. This is the last thing we have. Guys, focus up here. This is the last thing we have for lesson notes 2.5 is we saved this last one here because we got through, I believe we got through all the notes except for write a 2-column proof for this one here. So it should be the last piece, yes?
Yeah.
Yeah. Now, you all will have more space than I'm going to have up here to write, but we're going to write the 2-column proof for this here, and we're going to work it all the way through. Now, we're going to have our statements and our reasons. Now, whenever we start a proof, we always start with what? The given. Because whenever we are doing a 2-column proof, we always start with the given information. And what was the given information for this here? Right, MP bisects angle LMN. So y'all can write it a little bit wider out because y'all have a little more space. I'm going to just try to fit it in. Now, reason number 1, why do we know that this is true? It was given to us because we're always going to start with the given information. Okay, well that takes us to point number 2. Now, what are we trying to prove? That 2 times the measure of angle LMP is equal to the measure of angle LMN. So our last statement is going to be that. Because whenever we're trying to prove something, we always start with the given. We always finish with what we're trying to prove. So the last statement in the statements list should be that 2 times the measure of angle LMP equals LNM. That's what we're finishing. Now, we already have the given information down. MP bisects angles LMN. LNM, the whole thing, it is bisected. If we have a line ray or line segment that bisects an angle, it does what? It cuts it into half or 2 congruent angles. So that means that angle LMP is congruent to angle PNMN. Well, how did we know they were congruent? Because what? MP did what? Bisects the angle. Because that's really just the definition of an angle bisector. Because the definition of an angle bisector, it's a line ray or line segment that cuts an angle into 2 congruent angles. It cuts it in half. So really, all we've done is we've started with the given information. Because what the given information told us, well, it cut the whole angle into 2 congruent angles, yes? So that's just from that there. If these 2 angles are congruent, we know that the measures are the same. So the measure of angle LMP is going to equal the measure of angle PMN. Because we know their measures are going to be the same because they're what?
Congruent.
So we know that they're equal because of the definition of what? Congruency or congruent angles. I didn't need a second G in there. On congruent angles. Okay. Can I take that any farther? Well, no, we already said the measures are equal, yes? Now, what we're trying to prove is that 2 times the measure of one angle is equal to the measure of the other, yes? Since we're talking about measures, we need to take it all the way down to measures. If we're talking about the angles being congruent to each other or segments being congruent, we don't need to come down to measures, because if it's talking about congruency at the end, I don't need the measures. I just need to talk about the figures themselves, about them being congruent. So we needed to come down to this here. So have we talked about LMP already in this proof? Well, yeah, it's shown up several places. Have we talked about or defined what LMN is? So it is being bisected, yes? What is the angle itself? Have we defined it at all? Can I define it? Well, what can we say about the measure of angle LMN? So NMP, or I'll say PMN, plus the measure of angle LM, because the big angle is equal to the sum of the two
Smaller angles.
And this here is our, what? Angle, addition, postulate. Because the angle addition postulate says that if we have two angles, we can add them together to get the whole. Well, what did we just say about P and M? It's the same as what? LMP. LMP is equal to P and M. Those are equal because of the fact that they're cut into two congruent angles. So P and, guys, so P and M is the same as LMP, yes?
Yeah.
So what we could do is in this equation here, really we can say the measure of angle LM in the whole angle is equal to, well, we already said P and M is the same as, so we can say the measure of LMP plus the measure of angle LMP. Because we're replacing angle P and M with LMP because they are the same. Now this is our substitution. Property of equality. That'd be our substitution property of equality. Well, I have the measure of angle LMP plus the measure of angle LMP, yes? Well, how many of them do I have?
Four.
So we have 2 times the measure of angle LMP is equal to the measure of angle LMN. Is that what we wanted to prove? In our last step, I'll take simplified, or really the proper reason would be the distributive property, but we just simplified those two together. And that's it. And that's all we had to do for this here to show that this is true. So we really started off with what was given. MP bisects angle L and M. Well, if it bisects the angle, it cuts it into 2 congruent angles. So we listed that because of the definition of an angle bisector. Well, since they're congruent, it means their measures are equal. But we couldn't take that any further after being equals. But then we defined the whole angle, because we needed the whole angle, as its 2 parts. Okay, well, I do know that one of the parts are the same, so I replaced it, simplified, and we were done. So it's just really using the definitions and postulates that we have and combining them to show that this is true and working through it. Any questions on this here?
No.
And that is it for today. Yes. You have the rest of the time to work on this assignment or any of the other assignments you are missing.